Hi, Sam Benson here, Aperture Research Center. I'm sitting in front of our LEMS. The hood's behind me. There's a computer where the data is stored and a sensor box. And I want to go over just the procedure to turn it on and how that works. The first thing I want to note is that what we call the blower is attached to the hood. It's up there, and it draws all the smoke through the gate valves that can control dilution. This is the gate valve that mainly controls the dilution. So it draws through there, goes outside. That's the blower. The sensor box has a pump inside that draws a sample. See that thick black line is a sample tube. Gravimetric sample goes on the left. No filter in place there. So here we have Magnehelic gauge. The Magnehelic gauge is used to calibrate MagneSense, which is the digital pressure transducer. You need to measure pressure in the duct, dynamic pressure in the duct, to figure out the flow rate. So when we turn on the LEMS, first we make a data file. Demo 1. .csv, we always use .csv. Can be added later, but there it is now. And it says power up or reset the DAC. Click OK. So, we have a power button over there. Cold temperature makes the pump do that. A little slow turn on. Power up. It says waiting for DAC. You should be able to see that it's reading on COM1. There it goes. So it's reading on COM1. COM port is an old way of collecting data. It's run at a higher voltage, so it's not as susceptible to electrical noise as USB. It also has a slower data rate, so it's not susceptible to electrical noise. So it's collecting data. So with this sensor box, all the sensor boxes that include the Magnehelic, the Excel software is written to calibrate the digital pressure sensor based on the analog Magnehelic only when the blower is turned on between 1 and 4 minutes after the sensor box is turned on. Sensor box is running right now, and after 1 minute I'm going to turn on the blower. And actually you can see, so 1 minute has passed, but I said between 1 and 4 minutes, just the way it's written. So you can see in the first, second, third, fourth, the 1, 2, 3, 4, fifth column, that is the flow reading right now. So when I turn on the blower, flow reading went from 10,200 to about 14,000. Magnehelic was at 0, and now it's at about 0.47, maybe 0.46. Now, that's all great. If you get one of the new sensor boxes, which nobody has yet, then you won't have to do that. The last thing I want to show you is in the software. So I'm going to go ahead and turn that off because, well, I'll show you one more thing. We open up LiveGraph, look at the data. The color code here shows us the order of those. The way I got the column number for the data, it's in this data series setting, this color code. So the first row here is time, second is CO, thermocouple for water, PM, and then flow. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that works. So now I want to show you in the software itself what that does. And I'll turn off the blower and the pump. And we can close all that. So you just close things out. Now we go to Excel, open up this file. So I've got my, let's just open up that one. That one's the standard one. Okay, so I've got my cell F2 is the sensor box number, so that's written at 2041. And then I'm putting in the CSV file that we just created. So normally when we put in the start time, here. I put in 9:25 because I didn't write down all that, but when we put in the start time, the background is defined here. That's where the background's defined. So the end time of the background is always 2 minutes before the start time. So that's where 9:23 comes from. But the start time of the background is 4 minutes from the time that the sensor box was turned on. So you can see a problem here because the start time is 9:26 and the end time is 9:23. Doesn't make sense. That's because I chose a fake value. Didn't write down a good value for this test. But that's how that works, and you can look at the equation in Excel and see that. Here's the +4. The next one has the -2. As far as having to turn on the blower after 1 minute, that's in this cell, 0 flow. It's L5. So go up to the equation. So it says average, offset, and logger data. So when you go into logger data D4, the offset function starts at D4 and then it goes down and it looks for 0.9 minutes. So it's collecting an array. The offset function collects an array that spans between logger data D4 and 0.9 minutes past D4. And then it takes the average of that. That's what that function does. So that's about right here. There's 0.9 minutes. There's Largo data, D4. And the average is somewhere around 10,300. It differs depending on the MagnaSense or sensor box that you have. And that can be zeroed. I'll show you that right now. It can be zeroed by pressing that top button. It's pretty hard to read, but once it's going, you can hold down this button. We can try that right now. So for this kind of thing, you can usually open TeraTerm, go to serial COM1. This computer actually has a serial connection. It doesn't need USB. And so that's reading. Now, just turn on the sensor box. TeraTerm's running and sensor box is running, and it's asking us to type log. Did that, press enter. Now the data is streaming down and we're reading. What we're going to do is go just the simple procedure to zero the flow sensor. It's not going to do anything because I've done it recently, but this is all you have to do. I've already opened up the sensor head, so I'll just push that button for 4 or 5 seconds, and we'll see if that zero reading, if that column 5 changes at all. 1, 2, 3, 4, 5. I didn't see any change, but that's because it's already zeroed. That's the process though. It's just as long as there's no, the blower has to be turned off. There's no airflow through the room. So make sure you're getting an actual zero. That's the process to zero it. Thanks for listening. See you next time.